Okay, so to start with, exponential growth should have looked like that. Raise your hand if you had that one right. Okay, good. Do you guys remember the simplest exponential was like 2 to the x? And then to find a few points on it, you'd stick in like 0 and -1 and 1. Put in a 0, 2 to the 0 is 1. Stick in a -1 and it flips. Stick in a +1 and it'd be 2 to the 1, which is 2. And these 3 points would be your key 3 points. And then the asymptote would be along here. Did any of you actually have an asymptote drawn in on your graph? See how common it is to forget that? So don't forget that on your test. Okay, the next thing, exponential decay. This time include the asymptote. Make a little sketch of what exponential decay looks like. All right, now turn and show your little sketch of exponential decay to the person sitting next to you. And if you're lost, ask them for help. That's your person. Share with mine. Aben, did anybody share with you? Yeah. All right, good. The problem with that is that the kid on the other side of you doesn't have anybody. Oh, wait, no. So let's see. It's Alec, right? Did you compare with the kid in front of you? All right, good. So here we go. Exponential decay looks like this. And let's do a little instant IQ test. How many of you remember to put in the asymptote this time? Yay, that's much better than last time. Okay, remember that decay is when you have like 1/2 to the x. This number just is less than 1. Okay, all right, next up, go over here. Example of an exponential growth function. That just means not the graph. I already did one. I already wrote this earlier. So write an example of an exponential growth function. You can write f of x or you can write y equals. Vivian, what do you say?
I said 2 to the x.
That is good. Ooh, that's even better, but not required to say +3. That would mean it moved up 3. All right, good job. Now let's go over here. Exponential decay function. I just gave you this one before, right? So why don't you make it transform a little like she did? Do something to it. Well, there's 2 things you could have done. You could put a number up here. That's in with the x, so that's left and right stuff. Horizontal is on the inside, and that's considered the inside. And if I put like a -7 here, that'd be on the outside. So there's a little review. Here's the typical graph, but we've done so many of these that I feel like you could do this in your sleep, but I could be wrong. So instead of actually graphing it, let's just do the chart. If you can do the chart right, then you got this. I'll pause for a second while you try to figure out what goes here and here and here. Don't forget that negative in the front, and you put it on last. The negative goes on last. Okay, let's see if you put in the -1 right. The -1 goes here, and this is important. It flips, but not yet. It would flip it, but it first has to add to the 2. What is -1 plus 2? 1. So now it's -3 to the 1. Don't overthink this. Anything to the 1 just stays the same. So you should have had -3. Raise your hand if you did. Okay, good. Then on to the next one. If I put in a 0, you might be thinking anything to the 0 is 1. But the 0 has to do something first. First, the 0 gets added to the 2. So then it's really -3 squared. Now this brings up a very important point. A lot of you said +9 and you're wrong. You know why? Because there's no parentheses. If there was parentheses here, then it would have been +9. Without the parentheses, that gets squared first, and I said put the negative on last, -9. I'm curious, how many of you got that right? You caught that. Good job. Okay, then last but not least, we put in the 1. And if I put the 1 in there, it's really to the third, -3 to the third. Remember, you do the 3 to the third, and then you make it negative. 3 to the third is 27, then you make it negative. -27. Now, do you get that one off the graph? I don't expect you to graph things like that. But if they require 3 points, you're kind of caught in a catch-22, because that's not going to graph. You only have 2 points. What do you do? You put something else in. I'm going to squeeze in room for one right there. And if you were picking then, what do you think would work? I tried one and it got too big. You get if I tried two, it's going to just get even bigger. So what do you think I should put in right here? You can do 1/2, but I'm afraid that's going to make my power really weird. So let's use whole numbers. 0 worked. -1 worked. -2. Any bigger numbers than 1 are just going to get huge. So -2. -2 plus 2 makes power of 0. Ooh, I see. Anything to the 0 is 1. Seems like it would just be 1. But when there's a 0 right here, why is the actual answer is -1? It's really annoying. Didn't you say that it's always 1? This is 1 because there's no parentheses around that negative. The negative goes on afterwards, so the answer would be -1. Okay, so that's a quick reminder of what we've done so far. Then yesterday we had problems like this. Try to write the equation for this like I am. 40 yaks growing at 25%. Remember how that goes? If your starter number goes here, if it's growing by 20%, that's what it is. That goes right there above the 1. You know, whatever's above the 1 is the percentage of growth. Remember that kind? All right, so let's make one like this. This is about decay and costs. The costs of electric cars are going down. And so we're going to say that the cost of building an electric car right this second is $30,000 is the cost to build it. Does everybody write the equation for that? Y equals starting cost, 30,000. You may think it sounded really complicated, but there you go. That's it. That's the starting value. Now, what's the declining cost rate? It's going to go down about 10%. I'm going to do this. 1 minus 0.10. Would you have understood it if I'd have said 0.9? Because that's what that is. Either one of these is good, but I think the blue one's better because it shows me that that's 10% decay in costs. So the cost of my car right now to build it, it cost me $30,000 to build it. But if it goes down 10% every year for 5 years, notice I put that in the power. That's how you write the equation for that. $30,000 car going down 10% over 5 years. Now this is the part where you need to be able to put that in a calculator. I'm going to pause for a second while kids that don't have their calculator with them are going to come up and borrow one. No using the iPad because you can't on the test, and I don't want you to think you've got it because you understand it on the iPad. So your own calculator or borrow one of mine. Okay, so if you grabbed your calculator and you typed in 30,000, don't even have to say times if you put a parenthesis. Did you know that? If you just put the parenthesis right by the 30,000, the calculator will know you mean times. And I personally would have typed 0.90 because it's faster than 1 minus 0.1, and I know it's equal. And then I say to the 5th, and I hit enter. This is unlike the other day where I really strongly recommended that you put in the power first and then times it by 30,000. You can just go from left to right on this one, and it'll work. All right, get that answer on the calculator, and then if you're stuck because you're having issues typing it in, raise your hand, and I will come around and help you. Otherwise, in a second, I'm going to have you show your calculator to the person next to you, and hopefully you have the same exact thing on there. All right, and pause while you type that puppy in. Okay, so you should have had 17714, 17,714. And what that means is, if I'm right about the cost of electric cars going down by 10% per year, that 5 years from now, that'll be the cost. So it'll be way cheaper to make electric cars in 5 years than it is now. That generally is something that holds true. When something is a new technology, like electric cars are new, there's only a few of them out there really, about 1% of cars out there are electric, then they're still coming down in cost because it makes it cheaper and cheaper over time to make them. You learn how to do it better and faster and cheaper. Okay, so that is like 2 days ago. And then here's yesterday. Everybody, do you remember how to do e to the? Everybody do e to the power of 3. Now, if you forgot how to put in the e, I understand. Just ask me. And I'm going to walk around and make sure you know how to put in e to the 3rd. This came out to about 20.08, blah, blah, blah. And the whole problems yesterday were like this. So now today is just one more little formula like PERT that we did yesterday. And I'm going to introduce that to you. So, interesting question. I kind of like this one. Would you rather have $1 million or a penny that doubles daily for 30 days? And I totally get that you can tell, because you're smart, that the penny doubled daily is probably worth more. But you get how it starts out really, really small. You know, you get a penny on the first day, and you get 2 pennies on the second day, and then you get 4 pennies. So 1 penny, you get 2 pennies, you get 4 pennies. This is literally pennies. You get 8 pennies, you get 16 pennies, you get 32 pennies, and you can see it's getting bigger, but it's only 32 cents. I mean, add all of these up, it isn't even a buck. So it is amazing how exponential growth happens. And by the end, after 30 days, you actually have way more money than $1 million if you took the penny deal. Okay, so if you want to con your parents, tell them, you know, for allowance this month, how about just give me a penny on the first day, 2 pennies on the second day, 4 pennies on the third day. And I can show you exactly how that would go. It's an exponential growth thing, and we'll do that at the end of the hour. All right, so here is the new formula of the day. In this class, do I make you memorize formulas? No, we give you the formula. It's just, can you use it? That's the only question. Yesterday, you learned what P was, and I said it was the important thing. Okay? So the principal in our school is the most important person in the building. Like, they're in charge. The principal on a problem is like the most important number. It's like, how much money did you borrow? Or how much money did you invest? It's like your starting amount. Then this R, take a guess. Do you think it stands for raincoats? Rate is correct. And what do you think T stands for? Time. So this is a lot like yesterday, except yesterday had an E in it. This one doesn't. And if I said I started with $1,000, or let's say $100 to keep it simpler, and I go 1 plus the rate is going to be 4%, to the power of T, which let's say I do it for 3 years. If you put that in, it tells you what $100 growing at 4% would be after 3 years. Process that. Do you see what I'm talking about? The principal is how much you start with. The rate was 4%. Remember, I said 4%, but I put in 0.04. You always move the decimal 2 spots. And that 3 is how many years you do it for. And I know that some of you got confused when it switched to like daily. It's still the same. If they give you it as a day, you can just put the time in as days. We're not doing complicated ones. So that's your time. If we do it in days, it could be 3 days. All right. Now, if I was putting this in my calculator, I would not put 1 plus 0.04. I would put 1.04 because I can do that in my head. And I bet you can do that in your head. You know that's 1.04. And then I would do the power first, but it should work if you just go from left to right. 100. If you put in parentheses, it's the fastest way. To the third. Everybody do that with your calculator and let's see what we get. You had $100, you're getting 4% interest, you do it for 3 years. In the real world, you can do that right now. Banks finally are paying a little more interest. And so 4% interest is very possible. You keep your money in there for 3 years. And you'll have more than $100 now. Now, you might not think that it's worth it because it's like, so what? I got $12 or whatever. But this could be in millions. So like if you're Apple Corporation, you have $100 million. They might even have $10 billion. So when you're talking 3% on really big numbers, it matters a lot. If this is you and you only have $100, sure, if you've made a few bucks, maybe it's not even worth your effort for $100. But if these were in millions, Christian, what did you get for your answer?
112.4864.
And that would mean your 100 million grew to 112 million. Do you get $12 million? Means a lot, even if it's a big company. $12 million is a lot of money. You can hire a lot of employees with $12 million. So they have to be careful to not just waste their money. They have to like get interest on their money. Because if you don't get this 4% interest, because you just leave it sit in your bank account and they aren't giving you any interest, you're missing out on millions of dollars if you're a big company. All right. So here's your formula. Here's your problem. Stick the numbers in the right spots. McKenna's salary increases the rate of 4%. Ooh, we just did one like that. So hopefully you'll know how to do that. Starting salary is $45,000. What's her annual salary after 8 years? Zach, where do you think the 4% goes? Is it the P, the R, or the T?
The R.
Yep. So 0.04 goes right there. So I'm going to write this out. A equals P. Well, it'd be kind of nice if I knew what P was. Zach, do you know which one the P is?
45,000.
Yep. Vivian, 1 plus 0.04 to the... And you just use your calculator. I personally used 1.04 for the middle part. Go ahead, do that. See how much money she's making after 8 years. That is a very realistic scenario. Teachers get something like that at the beginning of their career. They might get 4% raises. So, and teachers a lot of times start around 45,000. So you could actually know this is pretty close to what a real teacher makes and how it grows over their first 8 years of teaching. It's not like huge growth, but you definitely make more after 8 years than you did in the first place. All right, type that into the calculator. In a moment, I'm going to walk past and see what you got. This one comes out to $61,585. And it might feel like, wow, they're making a lot more money than they used to. But there's also something called inflation, which means that 8 years later, it costs more to buy a cheeseburger, for example. So yeah, you might feel like you're making more money, but that's not actually lots more money if you factor in inflation. Yes?
What day is the test?
The test will be on, actually, I can't think of that right this second. So I'll get back to you later this hour on exactly when the test is. But it's coming, but it's not like it's Monday. Okay? Might be Tuesday. I think this might be our last day. I'm going to see. It might be Wednesday. I'll tell you later. But this is one of the last things that we have to do is this new formula right here. And if I tell you a principle, you just put it there. Rate is there. Time is there. I think rates get messed up the most. I'm going to say a rate. Would you please write what you think you'd put in? 1.4%. A lot of people are going to put in the wrong thing. What do you put for 1.4%? 1.4%. Of course, you don't put in 1.4. That'd be too easy. 1.4%. How far do you move the decimal? 2 spots. Veda, what do you say? 0.014. That is correct. That's what you put in for 1.4%. All right. I think it's time to move to this slide. Everybody try to set this one up, and I'll warn you, it's a little different. Because it makes it sound like they're giving you a time of 2050. you got to calculate that compared to the current year, which, just in case you're a little lost on that, is 2023. You can figure out how many years that is. All right, so your amount, put in your P, put in your 1 plus the rate. Ooh, rate's easy, 0.02. So there's a start. How many years is that? I'd use a calculator, totally okay. Okay, I'm gonna pause for a second while you set this one up. Okay, let's see if you figured this out. The principal was the main thing, which was the $3.49. $3.49 is your principal. I know it's a really small amount, but hey, that's what milk costs right now. $3.49. Then I go 1 plus 0.02 to the power of the years, which when I subtracted 2050 and 2023, I got 27 years later. That point is that's how much milk is going to cost you in 27 years. You won't be as old as me, but 27 years from now, that's how much milk will cost. Who had $5.95? Cool. That's how you do it. Last one. Car depreciation. This is a real thing, and I had that happen to me. I bought a brand new car, love it, but the value has gone down. For me, the value has gone down mostly because Tesla decided to cut their price of the cars a lot. So that means a brand new car is always worth less because, you know, it's used, it's not as cool as if it's brand new, right? But if they cut the cost of the brand new ones even lower, then the used car is worth even less. So this is really true. This is a value of your car going down each year, and it kind of sucks because you bought this thing and now it's worth less and less and less. So that is a downside to buying a new car, because look at this big jump at the very beginning. The $30,000 car might go down $6,000 right away. And a lot of people don't think about that when they buy that car. They're like, oh, sweet. They're just all excited about the new car that they bought. And you forget that it's plummeting in value at the beginning. Because get it, if you were going to go out there and buy a car, wouldn't you rather have a new one? So people don't want your used car as much as they want a new one. So that's why new ones go down a lot. This is called depreciation. And this is giving us our example for, like, what if it's not doing 1 plus 0.15? What if it's depreciating as in going down, then it's doing 1 minus 0.15. So if you have a $30,000 car and you multiply by 1 minus 0.15 to the 5, that tells you how much your car would be worth at the end. I gave you the equation. Dashel, what does the 15% part mean?
It's like how much it goes down.
How much it goes down, yep, each year. And then what's the 5 mean? Vivian, what's the 5 mean?
The rate,
Yeah,
I mean, the time.
the time. So over 5 years, it goes down 15%, then this formula would tell you how much your car is worth. All right, is 15% the exact right number? It totally depends on the car. Electric cars in general I used to be able to say, decreased slower in value. But now with Tesla's price drop, I think it's not safe to say that they're going to depreciate slower. They probably just depreciate like all the other cars. They go down in value. Nobody wants the used one as much as they want a new one. And that just makes sense. Okay, so that's an example of decay, because this number here is total of less than 1. It'd be really smart to put in 0.85 on the calculator instead of typing 1 minus 0.15. But I totally get some of you don't trust yourself enough, and you're just going to want to type it in exactly, and that's fine. All right. This is the part where we need to do the homework. So everybody find the homework. It is a worksheet. It's called U12L5. We'll do a couple problems. You can ask me questions if you get stuck. Davis, can you read me the first problem off the homework?
Okay. The car is valued at $5,000 and depreciates at a rate of 2.5% per year. What is the value of the car after 3 years?
He said 2.5%. That's the only thing I think you guys might have messed up. Does that make sense to you, what I typed? 2.5%, I moved the decimal back 2 spots in my head and I got 0.025. And it was for 3 years, so I put a 3 up there. If you can type that into your calculator, then you can get number 1 right. Davis, how many questions are there total on the worksheet?
6.
All right, I'm just gonna have you skip the last one, skip number 6. That leaves you 5 questions, and I already pretty much did the first one. That just leaves you 4 questions left. That's all you gotta do. Again, you may skip the last question, cross it off. And now you have a bunch of work time. That's all I got for you for today.